How you doing, Year 10s? Welcome to another video. These videos are on Unit 2, what are the bonding models. Make sure you've got pen, pencil, highlighter, highlight all the highlighting, copy down all the annotations, make sure that you've logged on to EduCanon and answered all the questions. Now let's get into these videos. Unit 2, what are the bonding models, 2.4a, and we look at covalent bonding in this video. A number of understandings and outcomes covered in this video. You might also have to watch it a couple of times because it is probably the most complex thing we've done so far. We basically want to look at what is covalent bonding. We want to be able to define a few terms like molecules. We want to know how non-metal atoms join together to form covalent bonds, and then we need to be able to draw those structures. Text ref down there as well. So, covalent bonding. Covalent bonding occurs between two non-metal atoms and they share electrons to obtain a full outer shell, which we describe as being an octet. Each shared pair of electrons is one covalent bond. So in one covalent bond we have two shared electrons. Covalent bonding between atoms results in the formation of a molecule. The simplest molecules are diatomic molecules, that is, they contain two atoms. So examples are hydrogen and chlorine. If we have a look at hydrogen, hydrogen has one electron in the outer shell. So the dot diagram of hydrogen has a H with one electron in its outer shell. The dot diagram shows the number of electrons in the outer shell. So if we get two hydrogens, remember in the first shell we can have two electrons, both of those hydrogens will share an electron each to form a bond. So between the two hydrogens we have two electrons, which gives us a single covalent bond, which we write as H bond H. Two shared electrons, one covalent bond. In this arrangement, both the hydrogens now have a full outer shell. If we have a look at chlorine, chlorine has 7 electrons in the outer shell. So if we do the dot diagram, we put in our 7 electrons in the outer shell, we have 3 pairs of electrons and 1 unpaired electron. It's this one unpaired electron that we'll want to share with another chlorine atom to form a covalent bond. So when we have two chlorines, we have our two chlorines with 7 electrons in the outer shell, and they want to share that one electron that's by itself to form a pair. And in that arrangement, when they share the electrons, we have a pair of electrons shared between the chlorines, which gives us a single bond. Now we have bonding electrons and non-bonding electrons. In this diagram, the blue dots would be the bonding electrons. The red dots are the non-bonding electrons. So they're there, but they don't actually take part in the bond. So covalent bonds, they result from atoms sharing electrons, and those shared electrons are attracted to the nucleus of the atom, and that's what holds them together. Remember, we're talking about the non-metals, so we're talking about groups 17, 16, 15, and 14. Let's have a look at group 17, fluorine's group. It has an electron configuration of 2, 7, so it wants to share one electron. That means any atom in group 17 will form one covalent bond. Oxygen with the electron configuration of 2, 6, it wants to share 2 electrons, so it will have 2 covalent bonds. Nitrogen with the electron configuration 2, 5, it wants to share 3 electrons to have an octet, so it will have 3 covalent bonds. And carbon is the special one. Carbon has the electron configuration of 2, 4, so it wants to share 4 covalent bonds to make a full octet. So using the information about groups, we can work out how many bonds an atom has to have. So let's have a look at the group 17, the non-metals. So we have fluorine, chlorine, bromine, iodine. Things in the same group will want to do the same thing. So fluorine, its electron dot configuration, well, it has 7 electrons in the outer shell, so we have 7 electrons surrounding the fluorine. One of them is unpaired, that's the one that fluorine wants to share. It wants to share that electron to have one covalent bond. So for example, A simple one could be hydrogen fluoride, HF. Hydrogen wants to share one electron, fluorine wants to share one electron, so they will be bonded via a single covalent bond. The fluorine will donate one electron, the hydrogen will donate one electron to the shared bond. So the fluorine will have now 8 electrons in its outer shell, the hydrogen has 2. We call this shape linear because it is in a straight line, the bond is straight. So a HF molecule has a linear arrangement, and we call that the molecular geometry. Chlorine being in group 17, it's going to do a very similar thing. It's got 7 electrons in the outer shell, it wants to share 1 electron, so that means that it will have a linear shape as well, and an example might be chlorine gas, Cl2. We have the 2 bonding electrons between the chlorines, 2 bonding electrons is a single bond, and then we have the pairs of non-bonding electrons surrounding the chlorine. And we would write that as Cl bond Cl, and again, that is linear. The bromine and the iodine will do a very similar thing, so that means that they're in the same group, they'll do a very similar process. So we could have HBr, hydrogen bromide, or we could have HI, hydrogen iodide. They're going to have the same shape and they're going to share the same number of electrons. Group 16, oxygen's group. Oxygen has the electron configuration of 2,6, so it has 2 pairs of non-bonding electrons, and then it has 2 electrons that it would like to share. So that means oxygen can form 2 covalent bonds. So that means if we have 2 hydrogen atoms to form H2O, oxygen will share with 2 hydrogen atoms. Now oxygen has the 2 non-bonding electrons in the red, they won't be involved in the bonding, but then the oxygen will share 2 electrons, one with each hydrogen. The hydrogen has 1 electron to share, so they will come in, and now the oxygen will have 2 covalent bonds to form the water molecule. If we were asked to draw the shape, that molecule has a bent shape, O, and then the 2 hydrogens coming down on a bent angle, and we describe that as bent. The second one, sulfur. Sulfur will have the same electron configuration as oxygen. It is in the same group, so it wants to form 2 covalent bonds. An example of this would be hydrogen sulfide, H2S. Again, the sulfur's got 2 pairs of non-bonding electrons. It wants to share 2 electrons to have a full outer shell. The hydrogens want to share 1 as well. So we have 1 hydrogen sharing 1, the other hydrogen sharing 1, and now we have an octet of 8. Because it's in the same group, it has the same structure, so it will also be a bent shape. Moving along to group 15, nitrogen. Nitrogen has the electron configuration of 2, 5, which means it wants to share 3 electrons. So it has 1 pair of non-bonding electrons and then 3 electrons that it wants to share to form a full outer shell. So it's going to have 3 covalent bonds. So for instance, NH3 ammonia, we have 1 nitrogen wanting to share with 3 hydrogens. Hydrogen can share 1 electron, so each hydrogen will share 1. The nitrogen will share 1 of its 3 with each hydrogen, and we get the formula NH3. Now the shape of a nitrogen atom is described as triangular pyramid. It looks like a triangle, and it's in the form of a pyramid, so it's called triangular pyramid. Phosphorus, in the same group as nitrogen, will do the same thing. So phosphorus will have 1 pair of non-bonding electrons at the top, and then it will want to bond and share 3 of its other electrons. So it will form 3 covalent bonds. So we could have phosphine, which has the formula pH3, and the shape is going to be very, very similar to the shape of the ammonia. Group 14, carbon, a very special element because it can form so many covalent bonds. So carbon has 4 electrons in the outer shell, 4 unpaired electrons. So what it wants to do is share 4 electrons to have a full octet of electrons. So for instance, CH4 methane, carbon will share one of its 4 electrons with each hydrogen atom. Each hydrogen atom will share its only one electron with the carbon. And then in this arrangement, the hydrogen is happy because it has 2 electrons in the outer shell. The carbon is happy because it has 8 electrons in the outer shell. In this arrangement is called tetrahedral. It looks like the triangular pyramid with a hydrogen sticking up the top, and it's known as a tetrahedral formation. Silicon, in the same group of carbon, silicon has 4 electrons in the outer shell, so it will want to do a very similar thing to carbon. It has 4 electrons to share, so it will form 4 covalent bonds. So if we have the molecule FISIF4, that will have the same arrangement as the carbon, except we will have a silicon in the middle and 4 hydrogens coming off in the tetrahedral formation. Each silicon will share its 4 electrons, one with each of the fluorines. With the fluorines also have the non-bonding electrons because they have 7 electrons in the outer shell. So when we draw the dot diagram, we need to include those non-bonding electrons. So here I am putting the non-bonding electrons in blue because they don't take part in the bonding. They would be termed non-bonding electrons. It will have the same shape as the methane molecule, and it will be a tetrahedral. Here I've highlighted the bonding electrons because those electrons are involved in the bond between silicon and fluorine. The other electrons, which will be highlighted, are the non-bonding electrons. Thanks for watching Year 10s. Don't forget, drop a like on the video, subscribe if you're new, and I'll see you next time.